There's just something about this one that I really enjoy. I don't know why, but I'm a fan. Okay, we're gonna take notes. It's gonna be grand. You're gonna do fabulous. Thank you. Let me recover. I appreciate you. This is gonna be great. You're gonna do great. Make sure that you keep up with the notes though. There will be an assessment on that.
Okay, so we're gonna start with lesson 5. This is on page 31. If I'm wrong, I'm sorry. I think it's on page 31. So flip in your book and find lesson 5, areas of parallelograms. It's got the same image that's on my screen. I think it's page 31, but again, my numbers don't match your numbers. Mine says it's page 1 actually. All right, so we're gonna go ahead and we're gonna just take a look at this. The Ed puzzle will stop randomly throughout the video to check in with your understanding. But for 5.1, a parallelogram and its rectangles. So we're looking at parallelograms. We've talked about this in the Desmos, and we can cut apart parallelograms. But one thing that not everybody recognizes is that, for instance, Elena cuts off just that end triangle that slides over to fill in this other side of the parallelogram. So those two slanted sides, they can fit perfectly together to create that rectangle. And so you end up with this rectangle in place of the parallelogram. But if you look at Tyler continued to cut at a perpendicular angle. Okay, so 90 degrees, but he didn't cut just the triangle off. He cut a larger space off. It still does not matter because it will still create the exact same rectangle. It just might look a little bit different when it gets slid over. But if you can see, both of these, if I draw this line, they're a little off, but these two rectangles are exactly the same regardless of how the two of them did it. Okay, so we don't have to write anything down. It doesn't matter about writing down the different strategies. What I just wanted you to see is that as long as you cut at a perpendicular from base to base, straight up and down, you can cut anywhere across that parallelogram and the two pieces will slide together to create that rectangle, and it'll be the same regardless of where you cut it. Some are just easier than others. My goodness, I can't get my thing to scroll. You guys get to watch this live. You're like watching this unfold, and it's trying to let my fingers do all the things. So now I have to figure that out. Okay, sorry, I'm done with my rambling. Hope that was a nice little sidetrack. Okay, so 5.2, finding the formula for area of parallelograms. So when we look at this is on a grid and we're not given any of the information. So we're not given the base, we're not given the height. What we have to do is identify the correct base and height for this. And it all comes back to the base and the height should connect at a 90-degree angle. So the base and the height. Now in some situations, the base may not be the bottom of the parallelogram. The parallelogram might be turned, rotated, and it might be on the side. And so that gets a little trickier, but we're gonna do that. Letter D is where we'll see that. So looking at this one's a parallelogram. It's a rectangle, pretty easy. We can identify the base as 4 units, and we can identify the height as 6 units. So all we have to do is fill this into our units, our base and our height units. So 4 for the base, 6 for the height. And then what they want you to do is they want you to count these squares to see what the base, to see what the area is. And in this case, it's 24. But we've gotten past this point. This is still kind of in the discovery stage where they're trying to get you to identify that base and height multiplied together will be the area. And so we're just going to go ahead and do the calculations as we go. So this is where a lot of kids make errors. You have to make sure that you're measuring just the base from corner to corner. So counting just those squares, 1, 2, 3, 4, 5. Now this is where we have to identify the height. The height is going to be the base to its opposite base at a 90-degree angle. So make these markings on yours, put your 90-degree angle, circle that, because that's the key, is the base and the height have to be at a 90-degree angle. Then I can count how many units. So 1, 2, 3 units. So this is a 5-unit base, 3-unit height. 5 times 3 is 15 square units is our area. Now, C is different because C has a unique situation where the base and the opposite bases don't actually line up. So this base here and this base here, this can be my base that's 2 units long, but to identify the height, I actually have to extend the base out to connect it with the other base. Okay, so there's my right angle that I'm searching for. My height is going to be here base to base, but this is where we see that where we're actually drawing an exterior triangle to connect the base to the opposite base using that triangle to show our height is 1, 2, 3. So this is a base of 2 and a height of 3. 2 times 3 is 6 square units. Okay, D is where we get to the situation where the parallelogram has been rotated. We're not going to use the slant as our base or our height. We're going to actually use this vertical line as our base, as if we turned this upside down. If it was laying on its side, it would look like this and the base would be at the bottom. But unfortunately, they've tilted it up, so we have to go based off of this one. So to do the height, we have to find a spot across from the base at the other base that we can connect with that straight 90-degree angle. So it's kind of counterintuitive because the base is on the side and the height is horizontal, which we're not used to. We're used to measuring the height up and down. So that's why this gets a little confusing. You can actually rotate your book and make it look like the base is on the bottom. So I can show you on my, there's all kinds of stuff, me as a rabbit. So I'll show you that when I have a situation where the base is on its side, so this is the situation, the base is on, they're labeling that the base is on its side, I can actually rotate my book and I can make my book make it look like the base is on the bottom. Gotta rotate a little bit more. Look like my base is on the bottom, and then you can see my 90-degree angle. This is actually taken out of the general book, so that's where that came from. So now that I've figured out what's my base, 1, 2, 3, 4, and my height is 1, 2, I can plug that in to find my area. So 4 for the base, 2 for the height, 4 times 2 is 8. So those are some different situations where the height can be that perfect rectangle, which is really easy because it's got that 90-degree corner. And then the letter B is what we traditionally see with parallelograms. C is when we have to draw the height on the outside. And D is when we have to draw the height from left to right because the base is actually on the side because that parallelogram's been rotated. So the expression for the area of any parallelogram is BH, base times height. So if you want to make a note of that, base times height if you're forgetting, or if you're good with using the dot now, base times height, that dot means multiply. But all of those are the same. This is just how we're going to see it algebraically from this point moving forward in middle school and high school. Okay, 5.3, we are now off the grid. So now that we're off the grid, this is where they've given us measurements, but we have to find the 2 measurements that work for the specific parallelogram. The first one, A, is very easy. They give us two measurements, but what I want you to focus on is make sure that you're circling the 90 degrees, because where that 90-degree angle comes in, that's the base and the height. So my base is 10, my height is 6, so I'm going to plug it into my formula. Base times height is 10 times 6. 10 times 6 is 60, and it's centimeters squared because they gave us those units of measurement. Okay, that is the most straightforward one. B, for letter B, we have 3 measurements. So again, the thing that we're searching for is we want to search for where is there a 90-degree angle drawn, because that's the base we're going to have to use. This one is a trick question because they're trying to force us to use 10 as the base because it's at the bottom, but there's no dotted line coming in with a measurement 90 degrees from that 10. They've got the 15, but this is not 90 degrees. So we are forced to use this. The base that we're actually going to use is our 15 centimeters. And I know that it looks slanted, but turn your book so it looks like the 15 is flat on the edge of your table. And then you'll start to see, oh, okay, this is really just a matter of it's rotating. And then because of this 90-degree angle, the height for 15 is actually going to be 8 centimeters. So this 10 is not useful to us because we don't have a measurement tool. We have to use the information they've provided for us, and that 90-degree angle is what that is. So let's do the math on that. Your multiplication charts do not go to 15, so you do have to set up a 1 by 2 digit multiplication problem. 8 times 5 is 40, carry the 4, drop the 0. 8 times 1 is 8, plus the 4 is 12. So we drop that down. 120 centimeters squared is our final answer for that one. All right, same situation for the letter C. It is rotated. There's actually no side that is sitting perfectly that looks like it's sitting on its base. So we have to identify where is the right angle. So the right angle is on the 7. So the 7 dotted line, that's going to be my height. But what's my base? Where this is connected, we don't have a measurement. But remember, opposite sides of a parallelogram are the same. So this is 9 centimeters. We could have also drawn the 90-degree angle here so that we see the 7 and the 9 connected. But regardless, we're going to do the area equals base times height, base being 9, height being 7. And we're going to multiply that out to get 63 centimeters squared. Okay, on this one, it's a beautiful parallelogram. The only thing is the height is not drawn and we don't have measurements. So we have to do all of that work. So we kind of have to do the legwork of this. Remember that when we pick our base, it needs to be perfectly left to right on a grid or straight up and down vertically on a grid because we have to be able to count the units. So my base at the bottom is 1, 2, 3, 4, 5, 6, 7. So 7 units. And my height going up, I'm going to go ahead and pick this spot right in the middle. And I'm going to draw my dotted line up to the opposite base. So base to base, 90-degree angle. And I'm going to count my units. So 1, 2, 3, 4, 5. So my height is 5 units. Now that I've identified my base and my height, I'm going to use my formula method where I plug in 7 for base, 5 for height, to get a total of 35 centimeters squared. Now, before we were using units squared, but this tells us that this box right here is a 1 by 1 square unit. And so that's why I use centimeters because it had a key up in the top right corner. So be on the lookout for those as well. So it says in parallelogram B, what is the corresponding height for the base that is 10 centimeters long? So explain your reasoning or show your reasoning. So what I want you to do is I'm going to have you do this with me. We didn't use 10, but let's say that we could use 10. What you would have to do, and I would recommend because it looks perfectly horizontal right there, is I would go from this corner straight down as if we were cutting off that triangle. And then there's my right angle. Okay, now I don't know what the measurement is for that. I don't know if it's 13. I don't know what it is, but I do know that that would be it. So that would be your showing your reasoning is drawing that in there. The height could be anywhere across this as long as it's base to base with the right angle. But that is how we could use 10 centimeters. Okay, so as long as you drew that on there, you're good to go on that. That was showing our reasoning. But let's explain that. So to use 10 centimeters, you would need the measurement from the 10 centimeter base to its opposite base at a 90-degree angle. So that's how we would use a height for the 10 centimeters. We would have to have that measurement from the 10 centimeter base to its opposite base at a 90-degree angle. So again, looking for that 90-degree angle base to base is how we identify those heights. Okay, two different parallelograms, P and Q, both have an area of 20 square units. Neither of the parallelograms are rectangles. On the grid, draw two parallelograms that could be P and Q. Okay, you can pause this and you can try to do this on your own. I am going to show you how you can do this, but first we have to think of 20 square units. So what base and what height can I do to get 20? And I need two of those. So I need to come up with factors that multiply to be 20. The first one I think of is 10 and 2. And the second one I think of is 5 and 4. And so in order to do that, what I'm going to start by doing is I'm actually going to draw my triangle. 1, 2, 3, 1, 2, 3, 4. Nah, I don't want to do 4. I need more space. So 1, 2, 3, 4. Okay. And then I'm going to, that has to be my height. So then I'm going to come down at an angle. So here's 2 units, 1, 2, and because my height is 4, I have to make this line, my base, 5 units, 1, 2, 3, 4, 5. But I also have to make its opposite 5. So 1, 2, 3, 4, 5, and then I can connect my parallelogram. So we have to be slightly off to make that slanted parallelogram that is not a rectangle. Okay. The other thing is the 2 by 10. So I'm going to actually do a height of 2. So I'm going to come down here and I'm going to do a height of 2. So here's my height of 2. But then I have to go over here somewhere. So let's do 3 units over here. And I'm going to make my slant. So 3 units, and then I got to keep counting. 4, 5, 6, 7, 8, 9, 10. And then up here I have to do the same thing because opposite sides are equal. 1, 2, oops, delete that. 2, 3, 4, 5, 6, 7, 8, 9, 10. They have to be off the exact same amount. So those 3 units, they have to be off so that they do show up. So here's my base of 10. On this one, it had a base of 5. And those are 2 parallelograms that will both have the same square units of 20 because it's 10 times 2 and then 4 times 5. There are other ways to do this as well. Okay, scroll, go all the way to the practice problems. So we're going to do some practice problems here. This is going to be a checkpoint, so I'm going to have you do this independently. But then I'm going to show you that you got it correct. Okay. So I'm going to go through this pretty quickly because this is going to be, I'm going to be stopping the video before these questions. You're going to answer the question and then you'll watch the video for my explanation to see if you got it correct. So right now there's going to be a checkpoint. And now I'm going to explain it to you. So select all segments that could represent a corresponding height if the side M is the base. So here is my side M. I'm looking for 90-degree angles to M. So that means E could be a height, F could be a height, J could be a height, and K could be the height. So E, F, J, and K should have been your answers. Okay, now it's going to pause. You're going to find the area of each parallelogram, so A, B, C, and then I'm going to go over it. So checkpoint. Okay, let's go over it. So for this one, I can just count 8 units squared. I don't even have to. For me, I'm just glancing at it. For this one, we should have identified that the base is the bottom, 1, 2, 3, 4, 5 units by 2 units is my height. So 5 times 2 is 10 units squared. Some of you might have cut it off and finished the square or finished the rectangle as well. For this one, I'd have to use my base is actually the side of 2. And then my height is actually going to go corner to corner inside at that right angle. And that makes my height 1, 2, 3, 4 units. So my height is 4 on the inside. So 4 times 2 is 8 units squared. All right, question number 3. We're off the grid, so we have to identify the correct base and height. Here's a checkpoint. Hopefully the ed puzzle stopped you. Now let's go over this. We're lucky enough to have just 2 measurements, but we have that right angle. So base is 9, height is 4. 9 times 4 is 36 centimeters squared. The next one, 90-degree angle connects 5 and 4. So my base is 5, my height is 4. 5 times 4 is 20 centimeters squared. The last one, here's my 90-degree angle. Okay, the 90-degree angle connects this base to this height. Opposite bases are the same, so B and H. They just want you to write the expression. BH equals the area. And so it would be B times H is what I would multiply. Units squared would be my area. So that's just an expression showing that you understand what that is. Here we have the Dockland building in Hamburg, Germany is shaped like a parallelogram. If the length of the building is 86 meters and its height is 55 meters, what is the area of the face of the building? So I'm going to show this to you before it stops. I'm just going to show you that the face of the building is here. It's saying that here is the parallelogram, that's the face, and they're telling us that the base, the length of the building, so here to here, is 86 meters, and then the height is 55 meters. And so they want us to find the area of that. So checkpoint, do your multiplication out for this. All right, now that you've done it, let's do 55 times 88. 8 times 5 is 40. 8 times 5 is 40 plus the 4 is 44. We put a 0 as our placeholder because this is not just 8, it's 80. Cross that out because we used it. We're going to have the same numbers. 8 times 5 is 40. 8 times 5 is 40 plus 4 is 44. Now we add the 2 partial products together. 0, 4, 8, 4. So 4,840 meters squared should have been your answer. If you made an error in your multiplication, we're going to be working on that in jump starts. All right. This is going to be a check-in, so I'm going to ask that you do this. Tell me your correct answers, or tell me the answers that you get for this. I'm not going to show these to you because I want to see how you do on that independently. So the video should pause. We're going to skip question number 6. Number 7 is the challenge question. So I want you to do number 7 on your own. Again, the ed puzzle will stop right after this and you will do number 7 on your own.